This is 2005 AIME II Problem 11. So we're told that m is a positive integer, and we let a0 through am be a sequence of reals, such that a sub 0 is 37, a sub 1 is 72, some term a sub m equals 0, and then this recurrence relation right here holds. So a sub k minus 1 equals a sub k plus 1 equals a sub k minus 1 minus 3 over a sub k for all k 1 through m minus 1. Then we're asked to find m. So first of all, let's figure out what we're looking for. So m is the index of some term in the sequence that's equal to 0. So basically, you have all these terms in a sequence starting with these first two, and then this recurrence relation gives you the nth term of the sequence, or the kth term, I guess you should say. And then at a certain point, one of the terms is equal to 0. So what we're going to do is we're going to use this recurrence relation right here. We're going to fiddle with it a bit, and we're going to use that to solve for m. So notice that if you multiply both sides of the recurrence relation by a sub k, you get something very nice. And I'll show you what exactly you get. And then that'll show you the motivation for doing this step. So multiplying the left side by a sub k, we get this, a sub k plus 1, then equals a sub k minus 1 minus 3. Okay, so what is this actually telling us? Well, it's telling us that the product of the kth term and the next term is equal to the product of the kth term and the previous term minus 3. So what that means is we start with term right here, we start with this term right here, and then we subtract 3 every time k goes up by 1 to get this product on the left hand side. So now let's go ahead and plug in a sub m minus 1 to this to get a nice equation that we can use to solve for m. So plugging in k equals m minus 1, we get, well, this is a sub m minus 1 times a sub m, so that's just 0, because we're told a sub m is 0, and that's equal to a sub m minus 1, a sub m minus 2 minus 3. So all that tells us is that a sub m minus 1, a sub m minus 2 is equal to 3. Okay, so now let's go ahead and rewrite this relation up here as a somewhat nicer equation that we can use to solve for m. So rewriting this in terms of or using a0 and a1, we see that a sub k plus 1 is really equal to a0, a1 minus 3 times k. And that's just because to get the next value in this, for this equation right here, so when k goes up by 1, we're just subtracting 3 from the previous value of the expression. So we can just start from some initial value and subtract 3 each time to give us the new value of that of the expression. So now we just want to see where this right here, a sub k plus 1, is equal to 3. And then we can use that to solve for m. So we get a0, a1 minus 3k equals 3. So 37 times 72 minus 3 over 3 equals k. So k equals 887. Okay, so plugging that in, we have a sub 887 times a sub 888 equals a sub m minus 1, or I guess this should really be a sub m minus 2, a sub m minus 1 to keep the order the same. So just to do a sanity check, we have m minus 1 equals 888. So then m must be equal to 889. So that's the entry, that's the term, the sequence, such that a sub m equals 0. And that's it.